All right, we are back. This is going to be the second part of our combining random variables videos. If you missed the first one or the videos on constants, I recommend watching those if you're not confident in how to do this. But the situation is we have a variable x, which is 1, and a variable x which has an expected value of 1 and a standard deviation of 3, and a variable y which has an expected value of 2 and a standard deviation of 4. So that is a situation we're in, and we want to subtract x from y. So we need to find the expected value of y minus x and a standard deviation of y minus x. So what we want to consider here maybe is if I have a group, well, let's say that x is a group of babies and y is a group of toddlers. So our distributions of babies and toddlers, and the babies have an average age of 1, and the toddlers have an average age of 2. I can already tell this is going to be a terrible analogy, but I'm going to roll with it. So if we wanted to find y minus x resembles or represents the difference in age between the average toddler and the average baby. So if I told you most toddlers are 2, well, not most, but the average toddler is 2, and the average baby is 1, how much older is the average toddler than the average baby? You guys would say 1. And all you've done there is subtracting 1 from 2. So we say that the expected value of y, which we're saying is our age of toddlers, minus x, which is our age of babies. They're not really the same thing, but just deal with it for now, is just equal to the expected value of y, minus the expected value of x. Like we were saying earlier, the expected value of y is 2, the expected value of x is 1. So we would expect that the average toddler is 1 year older than the average baby. That, of course, is not necessarily true, and I understand that using toddlers and babies and subtracting their ages isn't the most useful example, but you guys are going to have to roll with me because I'm not a professional yet. So we get this expected value of y minus x is just the expected value of y minus the expected value of x. That should be pretty straightforward. You guys should notice that it's actually pretty easy to calculate expected values, whether we're combining random variables or constants. Those should be pretty straightforward, and you guys should be money on those for the test. Finding the standard deviation is a little bit different. We're going to say that our standard deviation of y minus x, it's not as simple as subtracting the standard deviation of y from the standard deviation of x. In fact, we're not going to subtract at all. So we're going to say the standard deviation of y minus x is equal to the square root of the standard deviation of x squared plus the standard deviation of y squared. You'll notice that this is actually the variance of x and the variance of y. So if you want to think of it as variance of x, variance of y, or standard deviation of x squared and standard deviation of y squared, I don't really care. Whichever one, you guys should notice that they're interchangeable. So our standard deviation of y minus x is equal to the square root of the sum of the variances, basically. If you watch the adding random variables video, you'll notice that it's exactly the same formula. You can also write it as the variance of y minus x equals the variance of x plus the variance of y. The only difference between this equation and that equation is that we've taken a square root from both sides. So they're the same thing. Whichever one makes more sense to you, you can use. So we're just going to go ahead with what we got here. You guys got to remember, for these we add our variances. So we say that the standard deviation of y minus x, is equal to the square root of our standard deviation of x, which is 3 squared, which is our variance once we figure that out, plus our standard deviation of y, which is 4 squared, is going to be equal to 3 squared is 9, that's our variance of x, plus 4 squared, which is 16, that's our variance of y. And we'll do some simple addition. We get the square root of 25. And we're going to move that down here. You guys should know by now that the square root of 25 is just 5. It's a perfect square. So we're going to say the standard deviation of y minus x is equal to 5. This one's a little bit more tricky. Intuitively, it's not it doesn't make as much sense as maybe the other things that we do. So if you have to memorize it by formula for this one, go ahead. It follows kind of the same principle that we used in our adding, which is the Pythagorean theorem. But in this case, it's a little bit harder to visualize. So give it a stab. Try to remember probably this formula right here. Will be useful, or this one. They're the same thing. So whichever one is most helpful to you, get those down. Remember that it's a little bit more complicated to find the standard deviation when we are combining random variables compared to constants. So just keep that in mind, and I'm sure you guys will do great. If you guys need any other examples, let me know. Other than that, have a great weekend. This is the last video that I'm going to make, and then I'm going to go to bed because I'm getting older, and 9 o'clock is my bedtime, and that's what time it is right now. So have a great night. You guys are awesome. Keep studying, and that's it. Have a good night.